great to see everybody here after 2 years of lockdown and COVID. Nice to be able to see old friends and colleagues again.
Good morning, everybody. It is still morning. Is it something I said? My name is Andy Scott, as has been said. I'm Projects Director at C-Tec. We design and manufacture fire alarm systems in Wigan in Lancashire, so not far from the University of Central Lancashire. I think we need to be talking to each other. I'm involved in standards development in the UK and Europe, including chairing the UK committee responsible for fire alarm sounders and other alarm devices. And I was also a member of the panel that worked on the revision of the domestic fire alarm standard in 2019. I'm talking today about integration of fire alarms. I'm going to start with the situation as it is at the moment in purpose-built blocks. As has already been said, there are no fire alarms in the majority of purpose-built blocks, and this is absolutely deliberate. Often people see smoke detectors in corridors, but those are normally only used to operate smoke ventilation systems. However, of course, every flat will have its own domestic alarm to notify the occupants if there's a fire. And then occupants are expected to put the fire out or call the fire and rescue service. And of course, other occupants will not be aware of the fire necessarily, and so they're expected to stay put. If the alarm is raised by somebody outside the flat, of course there could be a delay. We don't know how long that would be because we can't possibly measure it, otherwise there wouldn't be a delay. But one thing we can measure is the arrival time in urban areas is about 7.5 to 8 minutes, according to government statistics. And as has already been said today, we must have got our data from the same place, the time to locate the fire after arrival and set up a bridgehead and get water on the fire can be as long as 20 minutes. And I believe that at New Providence Wharf, I heard somebody say that it was 35 minutes before the water was first put on the fire, but I've not got the provenance for that. So our proposal is that it would be better to call the fire and rescue service automatically, but only, of course, provided that false alarms can be avoided. And that is the key. So, what is the relevant standards? Well, we've already heard mention of the LGA guidance that was published originally in 2011 following the Lackenall House fire, where 6 people died. This is now the Home Office guidance because it's been republished with the section on PEEPs redacted, and I believe that it is being rewritten. Well, it says that it is being rewritten, but I haven't seen the new version of it yet. And I'm paraphrasing what it says in the section on fire alarms here. It assumes occupants will be able to escape and raise the alarm. It assumes that construction materials and fire stopping will prevent a fire spreading, and of course we hope that it will. It says that a communal fire detection and alarm system will inevitably lead to a proliferation of false alarms. And it says that the alternative, and by implication the only alternative to stay put, is one involving simultaneous evacuation. It also says it is unnecessary and undesirable for a communal fire alarm system to be provided. And I don't necessarily disagree with that, with the state of technology as it was when this was written. Some other things it says that a communal fire alarm system, if it is installed, should only be used to call a manned alarm receiving centre in unusual circumstances. It doesn't imply or say what those unusual circumstances are. And it doesn't consider the benefits of a communal alarm system being used to call the fire and rescue service, especially for vulnerable people. I'm thinking about people on their own in flats who, from the figures that I've seen, are quite often the victims of fires, but they die in ones and twos. And one thing it says that's very interesting is that if a risk assessment cannot prove the adequacy of the standard of construction, it is unduly pessimistic for simultaneous evacuation and therefore a fire alarm to be adopted, and suggests that you get a second opinion. So if you don't like the opinion you receive, you should get somebody else who gives you the opinion that is desired, which seems a very strange thing to say. So other relevant documents, fire alarm installation standards. This is my specialism, particularly part 6. These are required in flats, as we've already said. And one of the things that's said is that domestic alarm systems should be locally powered and controlled, so not part of any other building system. But the rest of the block is covered by BS 5839 Part 1. So there's a separation. You've got a block of flats, but it's only the dwellings themselves that are covered by 5839 Part 6, not the rest of the block. That's covered by 5839 Part 1, but there is no guidance in 5839 Part 1 to help a fire alarm company. So when they're faced with a design request for a block of flats, they follow what they normally do, and they design for a commercial application, probably putting manual call points all over the place, and obviously that has a risk in certain types of properties of causing false alarms. Another relevant standard is BS 9991, Fire Safety in the Design, Management and Use of Residential Buildings. And this, all these standards we talk about, as I think has already been said today, are based on life safety only. The property protection is down to insurance companies from a government point of view. But 9991 actually does talk about property protection, and there's a paragraph, the second paragraph there is a direct quote about the costs of fires, not just, oh good, we got there, we put it out, nobody died, that's great. Even when that happens, there can be significant costs and disruption in the flats that were not directly affected by fire. So again, we think that the earliest possible response can not only help save lives, but it can also help save homes and money. So if you were to integrate fire alarms in flats with communal alarm systems, what would you need to do? Well, the most important thing to do is get rid of false alarms in the flats and actually in the communal system. But any false alarms that do occur, because you can't get rid of them 100%, otherwise your fire detectors wouldn't pass the tests, must not normally trigger the communal fire alarm system. So you've got a false alarm in a flat, you don't want it immediately setting off the communal fire alarm system. So, but on the other hand, you need to make sure that if there's a real fire in a flat, that will set the communal alarm system off and do whatever's required. So you have to have a confirmed fire signal. I'll explain how that can be done. So the benefits, we believe, of integrating fire alarms is primarily in improving the response time, in getting the fire brigade to the flat more quickly and to the exact location of the fire. And for this, we would always use a professional alarm receiving centre because they can be programmed to give the right actions depending on the different premises. And they can also call premises management and so forth. If you wish, an integrated system can warn people in the immediate vicinity of the fire. Now, I have been told that it's common practice when you're setting up to fight a fire, to knock on the doors of the residents in the immediate corridor and get them out. If that's what you want to do, then they can be immediately evacuated as soon as you've got your confirmed fire signal. Another thing that we can do is make sure, of course, that if you get a fire in an unoccupied flat, perhaps because, as I think again, New Providence Walk, you've got an electrical fault, doesn't have to be anybody there for that to cause a fire. These will not go unnoticed, will not spread before the call goes out to the fire and rescue service. Other things you can do are monitor the domestic systems for faults, and you can even monitor whether the system is being tested by the user. And if you've got people who are vulnerable, you maybe go around and take action about that. So a bit more detail about Part 6. Part 6 defines 6 grades of fire alarm. The first two, F1 and F2, don't really come into this discussion today. They're the self-contained ones you buy in DIY stores. The most common ones that you see are D1 and D2, mains, powered smoke alarms with batteries. And then less well known are types Grade C and Grade A. Grade C is what my company manufactures, and these have a control panel and power supply in each flat, monitored equipment and wiring, and a standby battery. And Grade A is actually a commercial fire alarm. And Grade A systems are only used normally in either very large dwellings, perhaps even stately homes, or in dwellings where there's a lot of valuable property. And what you want to do is make sure that the property is protected, as well as life, of course. Part 6 also includes 3 coverage categories. The most basic is typically 1 smoke alarm in the lobby, on the escape route, on the single escape route. LD2 is the escape route and specific areas of high risk, such as typically normally the kitchen, but it could also be electricity cupboards, or if you've got a cupboard with a washing machine in, something like that, that would be considered an area of high risk. And then the best coverage, LD1, is to do all rooms, except toilets and bathrooms. So, a little bit about the components of these different systems. This is a slide about Grade D systems. These are by far the most common types of fire alarm in dwellings. They're mains powered, as we've already said. They're linked by non-fire rated cable. That doesn't matter because they're within a fire compartment of a flat, and if one goes off, they will all sound, so that's fine. But the cables and the equipment are not monitored for faults. So you may have individual fault indicators on the smoke alarms, but that's not being reported outside. You can get smoke, heat, and multi-criteria alarms, multi-criteria being a combination of smoke and heat in the same housing. And Grade D1 devices, which go into rented properties normally, have a fixed battery. And these have to be replaced every 10 years. And they actually put a sticker with the replacement date on the outside.
Tall Building Fire Safety Network delivers high-quality safety management training for anyone involved in the fire risk management of high-rise or tall buildings. Recognised by the Institution of Fire Engineers, we've been delivering fire safety training since 2011, and many organisations rely on our training for gaining competence in this field. Sign up for our training courses and conferences in 2023.
So there's a considerable cost and upheaval every 10 years with those. Also, the test and silence control is on the ceiling, on the detector itself, so you've got to be able to reach it. Although some companies do offer wall-mounted controls, but they're not required. Another action is that they are sounder frequencies greater than 2 kilohertz, and anybody who's got knocking on a bit like I am will know that I can't hear very well above 2 kilohertz. So that can be a problem for older people particularly. And those higher frequencies don't go as well through doors and walls as lower frequencies. I mentioned BSI 991 earlier, and that makes a recommendation to do with cookers on escape routes in open plan flats. If you've got a balcony, what it says in simple terms is that if you can't see through into that open plan area from all parts of the balcony, you need a fire alarm sounder on the balcony. And the ones that are available for Grade D systems are mains powered, but they don't have any standby battery. so they won't work if the mains fails. And you can link a grade D system to a communal system using a simple relay, but because of the false alarm risks that are present, you would risk a lot of unnecessary evacuations. I'm going to jump to grade A fire alarms now. These are the commercial ones, and this is a typical commercial fire alarm panel. Happens to be ours, but it is quite typical. Lots of buttons and controls. It uses fire-rated cables. That's what the standard says it must do, so that's a little bit more expensive, but it's fine. The equipment in a grade A system is monitored, and so is the wiring, so that if faults occurred, you get a fault warning. And it uses commercial fire detectors and alarm devices. It can be linked to an alarm receiving centre, so this would be very useful for your property with valuable artworks in it, if you've got one. Really useful is that the controls are available at floor level, but they are really difficult to use. And it needs to be serviced by a third party, and this requires regular access. So, the one we're concentrating on here today is grade C. And grade C is not very well known, but it was brought in to allow, for instance, for smoke detectors to be connected to intruder alarms as a form of domestic alarm system. And we produced our first hush system about 14 years ago as a way of reducing false alarms in HMOs. But this version, Hush Pro, a much more sophisticated version, was actually in development and shown at FIREX the same year as the Grenfell Tower disaster. So we've been thinking about this for quite a long time. It's actually a miniature analog addressable fire alarm system, a very sophisticated microprocessor-controlled system. It uses commercial fire detectors and sounders, but it's linked by non-fire rated cable. But the equipment and the wiring is monitored for faults. And because of the way the standard is arranged, grade C can always be used where grade D is specified. It can be standalone, but ideally it should be linked to a communal system. And I think you can see in the picture the controls are very simple. You've got a test button, which you have to hold for 3 seconds before it does anything, and you've got a hush button to stop it sounding should it go off. And it is suitable for life and property protection. This system can also be integrated with a communal system, but it's a rather more sophisticated selection. We can't use a relay because we're going to pass a lot of information, so we use a data interface. You can also link it to the cooker, the one I mentioned earlier that's in the escape route. We can shut that off should the alarm go off, and it can be triggered by a sprinkler flow valve should there be one in the flat. And the sounders that go on this system use the same standby power supply and can be installed on balconies. And it also does not need to be serviced by a third party. So there isn't a need for people to enter the flat to test it because it's being monitored all the time. So the key to all this, of course, is how do we avoid false alarms? Because if we can't avoid false alarms, this is all going to be a waste of time. So a typical solution could be to install a separate heat detector and sounder in each flat and connect it to a communal alarm system. Heat detectors are a very, very reliable indicator of a real fire, which is why the NFCC specified them for cladding risk situations. They will only trigger when the temperature is rising very quickly, so you will not get false alarms on the communal system they're connected to. However, of course, it could be some time from when the fire starts before the heat detector is actually triggered because it's in the lobby, and that may be too late for anybody, any vulnerable people particularly who might be in their flat on their own before the alarm goes off. And also because it's covered by BS 5839 Part 1, it's got to be serviced regularly. People have to get into their flat at least once a year. So our solution is to use commercial smoke detectors, and modern commercial smoke detectors use algorithms, use computer programs that resist false alarms from non-fire sources such as vaping, steam and electrical interference. And basically, if they see something very sudden happening, like a gust of steam, you open the bathroom door and a gust of steam comes out, it sees that and it says that is far too fast to be a fire, and it slows down its response. It just says, well, that might be a fire, but I'm not going to jump. And it sees what happens next. And if nothing happens next because the steam's gone, it gradually settles down again and it's fine, it doesn't false alarm. However, if there is enough real smoke, perhaps because you've got a pan in the kitchen area that's sending smoke out throughout the flat, if there's enough smoke gets to it, it will go off, because if it didn't, it wouldn't pass the EN 54.7 standard. So we're able to reduce false alarms, but we can't eliminate them completely with the smoke detector. But if we put a heat detector in the smoke detector, there's a standard EN 54.29 that says you can turn the smoke detector sensitivity down in the presence of the heat detector, provided that if the heat detector starts to see a rising temperature, you then turn that sensitivity of the smoke detector up again. So this does two things. It resists false alarms, but if there is a real fire developing, it actually goes off faster than an ordinary smoke detector. And if you connect the whole of this thing to the internet, to our cloud system, you can monitor this throughout the block over time and be certain whether or not you're getting any false alarms, because they will all be reported. Even though they don't set the alarm off, the system still knows that they have happened. So over time, that can be analysed. So one of the key features of this product is a concept we call fire levels. I said that if you had a smoke alarm, if there is enough smoke, it will trigger. On fire level 1, we assume in the first instance that smoke on its own is probably a false alarm. So the sounders go off in the flat, nothing goes through to the panel in terms of making it go, the communal system go off, and the user, the occupant, can press the hush button and it'll shut up for 2 minutes while they go and open the window and waft. And if they haven't wafted enough, after 2 minutes, it will probably go off again, and they can hush it again. Now, these events are being logged on the cloud, but they're not setting off the communal system. So it's no different, really, than your standard grade D system at that point. If, after 2 minutes, and you didn't go back and shut it up, and you've wafted the smoke, every 10 seconds, it will try to reset, and as soon as the smoke's cleared, it will reset automatically. So there's no other controls to mess with. If, however, you'll have at least one multi-sensor. Now, we think the safest thing to do is to have multi-sensors in every room, but they're slightly more expensive. So the minimum you can have is one multi-sensor in the lobby area. And if that temperature at that multi-sensor starts to go up, that confirms that there's a real fire, and that will go through to the communal system, and the communal system will do what it's being programmed to do. Now, we're not suggesting evacuating the whole building, although we don't know what the rules will be in the future, that you can program these systems to do whatever you want. But what we are suggesting is that it would call out the fire and rescue service via an alarm receiving centre who are properly set up to pass the information to the right people and make sure that they deal with it. And in the flat itself, it's a different tone to the normal alarm, and you can't silence it. So just running through it again, fire level 1, triggering of a smoke detector, and the heat detector in the kitchen. If you've got a heat detector near to the cooker, and you're cooking, I don't know, something on a wok or something like that, you can get enough heat to set off a heat detector on its own. So we treat that initially as a false alarm as well, just in the neighbourhood of the cooker. But if it's the heat element of the multi-sensor, then we don't treat it as a false alarm. Fire level 2 is the heat element of a multi-sensor, the different tone, and the report to the communal system. And as I said before, it can't be hushed. I mentioned that it's a data link from the Hush Pro system to the communal alarm. This is just a data cable. Now, some people say, oh, surely it should be fire rated. And we say, well, it doesn't really matter, because if it's worked, it doesn't matter if it gets damaged. If it gets damaged and it all melts together and causes a short circuit, it won't damage anything else. You've got a fire, what you're bothered about, it's already gone off. And it makes it very simple and practical to connect, because you're sending data backwards and forwards. You don't want to be using bulky fire-rated cable. The events are all recorded in the cloud, including every user test, every fault, fire level 1 false alarms, and fire level 2 confirmed alarms. They all go through that data link to the cloud. This, for the electrical types in the room, is the wiring, a block diagram of the wiring. On the left, I'm showing smoke detectors. And these, as I said right at the beginning, are normally operating the AOVs. We wouldn't expect these detectors normally to be set to sound alarms in the building. They could be, but we wouldn't expect them to be. The only extra cost is the interface on that existing, or on that AOV system, linking to the Hush Pro system. And then in the flat itself, you've got a mains power supply, the controller, fire detectors and sounders, cooker shut-off relay, an input from the sprinkler, should you have one. I noticed that actually says sprinkler. I must get that fixed. And we've got a balcony sounder in this particular instance as well. Now, somebody mentioned evacuation alert systems, and strangely enough, we make those as well. Hush Pro can actually provide you with the functionality of a BS8629 system, because we're well aware of what the BS8629 standard says about it being standalone. But we're also very well aware of the fact that it isn't mandated anywhere except in Scotland. But if you want that functionality, it can be added to this system, and the only cost is that big heavy box on the wall there. And it is big and it is heavy. By the way, empty, it's 70 kilos. So it's about 90 kilos with batteries, so you don't stick it on a stud wall. Well, you can, but it'll probably fall off. So you can use an 8629 controller or anything else as a secure means of switches, and we normally evacuate a floor at a time. But what this does is it gives you a completely different alarm tone, or even a voice message. And I've had quite a few fire officers say, would be much better if it just said, this is the fire and rescue service, please evacuate, something like that. And we can do that. So that's actually fire level 3. And then, nearly done now, Envision IoT data gathering analysis, the cloud. Everything's monitored, everything gets reported. Any emergency events we do not expect an internet-connected system to be used to call the fire and rescue service. We do not consider it to be reliable enough. So we still use a conventional link to an alarm receiving centre for fire events, but the same events are logged on the system, and you can get push notifications, and if you've got a lot of blocks of flats, you can get all the information from those different flats coming to your central location and going out again to duty holders and such like on their mobile phones and tablets and so forth. And one of the other things we can do is we can indicate exactly where the fire is in the building, live in real time. As long as there's a decent internet connection on your mobile phone, you can see that there is a fire event, confirmed fire in flat 501 on the 5th floor of this particular block. And that is intended for the premises management. But actually, there is no technical reason, maybe some GDPR issues, but there is no technical reason this could not be made available to the fire and rescue service, because the app is on the App Store now. It's called Envision. You just need the password, which we have to give you. So this could go to the Fire and Rescue Service. From a duty holder point of view, it provides an audit trail, and from a maintenance point of view, it can also be used to record that work's being carried out. So, summary. False alarm resistant, fully monitored fire alarm system with simple low-level controller. It integrates to a C-Tec communal alarm system. It doesn't integrate to other people's alarm systems, but simply because they don't have the right data on their system for us to connect to. Connect it to an alarm receiving centre for fire and rescue service response. You can use it for evacuation alert, full logging, and by the way, a lot less plastic, fewer batteries than a grade D system. So from an environmental point of view, it's got a little green tick there. Don't make a big thing of it, but it is a fact. And finally, it's a 10-year battery that's replaceable. So when that battery comes to the end of its life, it's take the front off. Doesn't need an engineer to do it, but you take the front off, put a new battery in, and it's okay for another 10 years. And by the way, the Building Research Establishment did a report that says that commercial smoke detectors are still working fine after 35 years. You don't necessarily have to replace detectors until they get very old. 30 minutes. Thank you. Thank you.